All right, good day, everybody. I hope you're all fine. Welcome back to my channel. It's been a long time, Yana, but we are back. So today we'll be discussing isomers. Still continuing with organic chemistry. Okay, so now let's go. We have different types of isomers. So isomers are organic compounds that have the same molecular formula but different structural formula, meaning or it's about the arrangement of atoms, right? So now we differentiate between different kinds of structural isomers. We have the chain isomers, positional isomers, and functional isomers. So number one, we can start with what? The chain isomers. So now, what are chain isomers? Chain isomers are molecules with the same molecular formula. Whenever you are defining the types of isomers or whatever isomer, these are the main words that you have to write there. The same organic molecules that have the same molecular formula but different types of chains. So, but the last word is just different. But the first ones, molecules with the same molecular formula. Each and every isomer has the same molecular formula. So now this ones, it is what? Same molecular formula, but what? Different what? Types of chains. So now we are going to talk about different types of chains. Same molecular formula, but different types of chains. Is it fine? So now we are going to start. For instance, we can just take one long chain or a branched chain, a branched structure. So this is how you can do it. So now about chain isomers, you're going to, whenever you see a methyl group or alkyl group, a methyl, you remember we did it on the haloalkanes. Whenever you see it, you can consider it as a what? Chain isomer. Okay. So now let's say we have what? Butane. And butane, it is what? C4H what? 10. So now you're gonna draw it. 1, 2, 3, 4. This will be my hydrogen. Okay, so this is butane. So now, as you can see, butane, it is C4H10. Same molecular formula, but different types of chains. So this is another chain for butane. But butane can be written in another way. Okay, so now let me show you something. This is how we write it. When we want to write butane in another way, we are going to include the alkyl group, which is what? Methyl. So now meaning that the other name for this one, C4H10, it is going to be what? Methyl propane. So let me show you how this thing is. So we have H, C, H here, C, and then H here, and then the line we have what? CH3. Then the last C. Can you see it? So this is methyl propane. But now check something. They have the same molecular formula but different types of chains. So this one, it is C4H10, C4H10, because carbon atoms 1, 2, 3, 4, 1, 2, 3, 4. Then the hydrogen atoms, same thing. So both of them are what? They have the same molecular formula but different types of chains. Can you see it? That's how it is. So the more the carbon atoms in the molecule, the greater the number of different branch structures that can be formed. Is it fine? So now maybe you have a hydrocarbon with maybe 5 carbon atoms. Okay, so now that will have what? 3 chain isomers. So now let me show you something here. It is gonna have 3 chain isomers. I'm gonna choose an example now. Like as you can see, butane gave me only 1 chain isomer, right? So now if I choose pentane, pentane is gonna give me 2. This one gave me 1, but pentane is gonna give me 2 other chain isomers. Basically about isomers, you can draw a structure, né? The same molecular formula but different structures. That is the main thing. So now let's say I have pentane, né? Pentane, it is C5H what? 12. Okay, so now let me draw it so that you can see it. Let me use the very same mark. So I have H here, and then I have 1, 2, 3, 4, 5. H, 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 oh, H, H. Is it fine? C5H12. Now let me show you the other two chain isomers of pentane. So now, as you can see, we want to maintain then the same molecular formula. So this is the first one. The first one is what? 2-methyl butane. Whenever you see a methyl, know that that is an isomer. It's a chain isomer. Is it fine? So now we have what? 2-methyl butane. So now meaning that we have how many carbon atoms? Like this one is what? 4 plus 1, which is the one for methyl. So I have here this one 1 2 3 4. Then here H, but on the second carbon atom, that's when I have the what? The methyl. H. Is it fine? This is the first one that I have. So as you can see, 1 2 3 4 5 carbon atoms. Then even if you can count the number of hydrogen atoms, they are the same. It gives you C5H12, 2-methyl butane. Is it fine? So now 2 tells you the position of the alkyl group, which is the methyl, and then methyl is this CH3, butane, it tells you another one. And then now the second one, it is what? 2,2 dimethyl propane. So now I want to give you an activity to throw this one. 2,2 dimethyl propane, meaning that methyl, this one CH3, is on the same position, meaning that you have the other one here and the other one up there. So now I already gave an answer. So you're gonna draw your structure, but that structure is gonna have 3 carbon atoms like this. But now on position number 2, you're gonna have a CH3 here and CH3 lapapizol. So now they all have the same molecular formula but different types of chains. Okay, so now let's discuss the similarities and differences. All 3 compounds of 5 carbon atoms and 12 hydrogen atoms have the same molecular formula. So now they are the same, and they all belong to the same homologous series, which is alkanes. Okay, and then they have different structural formula. That's what we have because they are different. So now that's how it is. Is it fine? So the first one, it is only alkane, straight chain alkane. But now the last two, they have what? Alkane, which is branched. If you see an alkyl here, which is like this, know that it is what? Branched, because it has what? Alkyl groups. Okay, and they have different names, and then now they differ in their physical properties about boiling points and melting points, but they're gonna go there on physical properties. But I hope you understand the chain isomers. Now we can go to positional isomers. So now chain isomers, these are molecules with the same molecular formula but different types of chains. So here molecular formula is the same, C4H10. So now this is a butane straight chain alkane, but this one is this branched. As you can see, it has a what? Alkyl group, which is a methyl, CH3. So now it is the same molecular formula but different structure. So this one and this one have different structure. So now they are the same. They belong to the what you call, to the same homologous series, which is alkanes. And then the difference is that they have different structure and different names, but this is the chain isomers. Let's go to positional isomers. So now let's go to positional isomers. These are molecules with the same molecular formula. You see the definition is the same on the first lines. Molecules with the same molecular formula, but they have what? The different, what you call, but the functional group has the what? Different position on the parent chain. So molecules with the same molecular formula, but with substituents or functional group in different position of the parent chain. Okay, so now let's go. Now, a halogen atom or another functional group, maybe a double bond or a hydroxyl group, can occur between two possible positions. Remember, when we're doing alcohols, ketones, we're now talking about the position of that special thing here. So now it is back again. So now let's go and do the thing. So I'm gonna start with what? Halogens. So now let's say I have what you call a C4H9, then Cl. C4H9 and a chlorine. Okay, so now it is gonna be H 1 2 3 4 H. Let me write my chlorine here. H H, 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 H. So this way I have my what? My chlorine. So now this one is called 1-chlorobutane. This one tells you that the chlorine, it is in position 1, it is in carbon number 1, and then butane 4 carbon atoms. That's how it is. So now this is about the position. Is it fine? So now the position can be about the double bond, can be about the triple bond, can be about the hydroxyl group. You remember this OH, right? Can be about this one, can be about this carbonyl here. You see, that is what it can be about. So now the positional isomer of this one can be again this one, the same molecular formula but different structure. So now in the second one, as you can see, on the first carbon atom there's a hydrogen, and then now on the second what you call carbon atom, that's why I put my what, my Cl there. So as you can see, it is now in position 2. So now this is 2-chlorobutane. So that is the difference only. Is it fine, guys? That is the difference only. Now let's go to another one about a double bond. Okay, so now let's go. We are gonna go to what we call alkanes, about the double bond. Okay, let's say I have but 1-ene. I told you that this but tells you that you have 4 carbon atoms. This one tells you the position of the double bond. Then ene tells you about the double bond. So we are gonna have C here, the double bond, H, H, then C, H, C, H, H, H. So this is but 1-ene. The double bond is in the first carbon atom. Is it fine? That's how it is. Let's find the positional isomer of this one. So now it is gonna be what? Let me say but 2-ene. So now we are gonna have H here, C, H, H. Then now this is where we're gonna have what? The double bond. Yeah, I hope you understand. These are my hydrogens there. So now the double bond, it is in carbon number 2. You can understand it. So this one is what? But 2-ene. Okay, yeah, but you're gonna do more examples as time goes on and check the what you call the ones for hydroxyl and stuff. So now let's go again, similarities and differences. Okay, so now the two compounds in both examples have the same molecular formula. That's what we have. Okay, C3H6, C3H6, C4H9Cl, C4H9Cl sharp, but they have the same, and at the same time they have the same functional group and belong to the same homologous series. This ones belongs to what? Haloalkanes. This ones belongs to alkenes, but their names are different. As you can see, the names are different and they have the different physical properties. But I told you not to worry about physical properties as we are going there soon. So now let's go to the last one, which is what? Functional isomers. So now functional isomers are molecules with the same molecular formula but different functional groups. Done. Okay, different functional groups, molecules with the same molecular formula but different functional groups. Remember, I was telling you about the functional groups. Now this is a functional group. This carbonyl is a what? Functional group. Okay, so now this is what we can have. So now for the first one I can have what? Let me take the cool thing. So now what I can have a what you call propanoic acid. So this one is a carboxyl group. Okay, functional group, carboxyl. So propanoic acid. So 3 carbon atoms, 1, 2, 3, H, 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 H. Remember, I told that the carboxyl, the cool must be always at the end. Okay, so now this is what you have, propanoic acid. So now what is the functional group of propanoic acid? It is what? Methyl ethanoate. Now I will have to tell you something about these ones. So as you can see, this one is what? Methyl ethanoate. This one is now about esters now. Okay, so this HC H O C O C H H, H. You're gonna understand this thing. Please go and watch the video for what you call for esters, because you're gonna understand this whole thing. Okay, so both of them have the same molecular formula and they have different structural formula but belong to the same homologous series. So now, to summarize what I just told you today, this is what you have to know about functional isomers. Ketones and aldehydes are functional isomers. They have the same molecular formula, CnH2NO. CnH2NO. Can you see it? They have the same molecule, they have the same functional group, but different. But they have the same molecular formula, but different functional group. But these ones are what? Functional isomers, because they have the same molecular formula. Is it fine, guys? So now let's go again. You know that ketones have the what? The carbonyl group, which is the what? The functional group. So this carbonyl group, it is attached to what? To carbons. They're on the other sides. But this one it is what? The carbonyl group, but this one is called the formyl group. Formyl group meaning that the carbonyl is attached to a what? To a hydrogen. Is it fine? That's the revision. So ketones and aldehydes, same molecular formula but different functional group. And again, the last ones, carboxylic acids and esters, they have the same molecular formula. Okay, and then they have the different what? Functional group. That's all with what you call the isomers, guys. I hope you enjoyed. Thank you very much.